بسم الله الرحمن الرحيم. اللهم صل على محمد وآل محمد عجل فرجهم والآن أعداءهم. Dear colleagues, in the third International Conference on Materials Engineering and Science. Assalamu alaikum wa rahmatullahi wa barakatuh. With you, Dr. Hussein Shakir al-Bahrani from the Faculty of Engineering, University of Kufa, Najaf, Iraq. I present our paper in this conference. Its title is Determining a New Way to Detect Hydrocarbon Polluted Water at Vertical and Horizontal Spaces. Introduction. Hydrocarbons are categorized as hazardous contaminants in the environment. Water pollution with hydrocarbon represents a challenge in many places around the world. Detecting this pollution in labs needs time, which is expensive too. Therefore, it is essential to search for fast and efficient methods to detect and sense this pollution. This study aims to discover the ability of the Aqua device to sense, detect, and find hydrocarbons and polluted water with these hazardous organic compounds. Besides, to determine their location and depth quickly, efficiently, and accurately. The manufactured company of the Aqua doesn't discover these uses in its device, and no one uses them before for these purposes. Materials. The Aqua device. The water detector Aqua, as we see its photo here, works by long distance sensing system and is supported with acoustic identification systems at detecting frequency from 1 to 9 kHz to locate the path and point center of the water. The Aqua device has the ability to search for water at circle radius equals to 200 meters. It also senses water for vertical spaces up to 200 meters. It can find water at depth begins from 25, 50, 100, 150, and at last 200 meters. Moreover, it can recognize between normal, salty, and mineral water, in addition to all types of water. Methods. The first experiment in this study is detecting hydrocarbon products. The Aqua device has the ability to sense and detect gaseous products of hydrocarbons, such as cooking gas. It also detects benzene and engine oil, and these two products are liquid state of hydrocarbons. But the device couldn't sense and detect the solid state of hydrocarbon. As we see here, he doesn't indicate to the Vaseline product, which is a solid type of hydrocarbon. We conclude from these experiments that the Aqua device could sense and detect gaseous and liquid hydrocarbons, while it couldn't detect and sense solid state of hydrocarbons. The second experiment in this study is detecting water pollution with hydrocarbons. In the first experiment, we conclude the ability of Aqua to detect gaseous and liquid hydrocarbons. But in this experiment, we prepared polluted water with gasoline and engine oil and made many tests to find the ability of Aqua to detect these targets at different vertical and horizontal spaces. The Aqua device can detect the targets at horizontal spaces from 0 up to 200 meter. But after 200 meter, at 220 meter, the device couldn't recognize the targets. When putting the device over the target directly at 0 meter and put the type of water on mineral option, the device rotates clockwise, as we see here, at different vertical spaces, 1 meter and 10 meter. In the second group of tests are done in the field at a well polluted with crude oil. The device can recognize the polluted water with hydrocarbons, crude oil, at different horizontal and vertical spaces up to 200 meter. After 200 meter, the device couldn't recognize the targets. The following diagram represents Aqua response to different types of hydrocarbon products: coke gas, benzene, engine oil, and Vaseline, via rotating velocity. When putting the option of the device on mineral water and put the device over the target directly, the device begins to rotate clockwise. This velocity differs from product to other. The fastest rotating is to benzene, and for Vaseline there is no rotating velocity because the device couldn't recognize the solid state of hydrocarbons. The following diagram represents the relationship of Aqua response to different water samples with their hydrocarbon concentrations. The rotating velocity of Aqua device for different samples of polluted water with hydrocarbon are compared with their concentrations in milligram per liter. As we see from the scatter diagram and the trend line, regretted trend line, the relationship between these two variables are strong, And when we calculate coefficient of correlation and coefficient of determination, the values of these two coefficients are high and significant at confidence limits. The conclusions of this study are: the study concludes the possibility to detect and sense gaseous and liquid hydrocarbons in addition to polluted water with these compounds via Aqua remote sensing device at distances and depths don't exceed 200 meters. This discovery helps people who work on Aqua device to recognize the type of groundwater in deep aquifers, whether it is mineral groundwater or just mixed with hydrocarbons, either naturally or man-made. The device can be used to sense oil reservoirs and can give primary indications of oil existence with the least cost and effort. These some photos of detecting water at different locations in Najaf, Karbala and other regions. Thank you for listening. Now if there is any questions or queries.